Yesterday, we were introduced to Salila, and can someone please tell me what was the problem that Salila was facing?
She wanted to take the turtle.
She wanted to take the turtle
out the dirty river.
Thank you. She wanted to take a turtle out of the dirty river. Now, why was it so important that the turtle not be in the dirty river?
So the turtle doesn't get sick.
So the turtle doesn't get sick. I don't remember what country it was in.
India.
Okay, so now we have the Ganges River, which is a very important river in India, and it was very polluted. So the main problem that Salila was facing was that the water wasn't clean for the turtle. A couple of seconds in your group, what are some of the ways that you could tell that water is clean?
The color, it was clear and not dirty and brown.
What are some ways we could tell when the water is clean? Give me one.
When you don't see trash or nothing under it, just the sand.
You just look down and see sands, okay?
When it's clear and blue.
When it's clear and blue. So what's the main thing that everyone keeps saying? That the water looks what?
Clear.
Clear, right? That's how you kind of have an idea. But let me ask a question, even if the water looks clear and looks clean, do you think it's still safe to drink?
No.
Okay, good. I want you to keep that in mind, because what did we learn yesterday could be in the water?
When you look like at a microscope, you can see if there's bacteria.
Microbes or bacteria. Now, I have 3 jugs of water here. Now, based on what we said, would you consider any of these jugs clean water?
No.
And can you see particles? Yes. Okay, and which ones can you see particles in? Kaylin, tell me one.
The one in the middle.
The one in the middle, one with the soil. There's particles. Now, I'm going to kind of walk around with it so you guys could see. And then let's look at this one. This is tea. I'm going to shake it up a little bit so you guys can see. Okay, you can't see anything. Now with this one, I want you to look. Besides the bottom, I want you to just look through the water. Does the water look clear? No. It looks white. Top looks a little clearer. What's another word that we could say for what looks white? Foggy, cloudy, right? The water looks a little cloudy. So we can see sometimes water could have different particles, different contaminants. Some that we could see, some that we can't. So now what we're going to do is we are going to work on the first part of our engineering process. Is we're going to ask questions. We're going to look at the properties of the materials that we are going to be testing. Today we're only testing, it says 3, but it's technically 4 materials. Okay, because remember, we're asking a question. What are the materials we could use to create our filter or to use in our filter? We will be using, and I have it counted for a reason, 5 coffee filters. And we've worked with this before, okay? So I want you to keep that in mind. We have 5 coffee filters. We are going to be using a screen. And then we're going to be doing a mixture of gravel. And then you have very fine white sand. The sand and the gravel you will be kind of testing together because you need both, okay? And I want you to think of some of the properties these materials have, because then we're going to come up with a list on the board about how each material acts. Make sure I have material. Don't laugh at my lines. We've used this word before. Properties. Or what would be another word for property?
It's basically something that somebody owns or belongs to.
Okay, properties is a multiple meaning word. It has that meaning. But in this part, if I say what is a property of a material, what am I asking you?
It's like, what can you see about it?
What it is made, like something that is made of.
Okay, maybe something that it's made out of, or that specific material. Okay. A material that we're trying to use as a filter, it should be able to do what?
Clean water.
Okay, clean the water.
Get all
Particles?
the bacteria. Yeah.
Okay, good. Take the particles out, take the bacteria out. So these are pretty much how the material behaves. Okay. Okay. So we're looking at the materials to make sure that we know what they are, and then to kind of look at the properties.
To identify the texture.
How the water flows through.
Good. How does the water flow through it? What do we notice about the screen?
It's got holes.
Good. There's holes in it. Holes that are visible, meaning we could see.
Very small, though.
What happened?
They're very small.
They're very small. but they're visible. You can see the holes, right? You have to kind of look at them, but you could definitely see the holes. So if I could see the holes, what does that tell me about if I pour something through this?
It's going to go through.
It will go straight through. But let me ask you a question. If I were to pour, I guess, this one, what do you think would happen? The dirt would stay on outside. Thank you. So it pretty much would screen out. It would take out the bigger particles, the particles that we could definitely see. Hold the cup of gravel and the cup of sand up for a minute. Hold it up. In your group, hold it up. Now I want you to look at the spaces in between the sand, the grains of sand, and the gravel. What do you notice about the spaces in between each?
The rocks have more space in the sand. You can't see the spaces.
Very good. The gravel, if you look, has more space in between, right, each other, while the grains of sand, it's very difficult to see them. Their spaces is very tight, okay?
It says 2. Put an X through the material that you predict will work the worst to filter the contaminated water.
Let's go, groups. You have 2 minutes left.
Which one? Is it screen, paper filter, or sand and gravel? Okay, one thing
Gravel doesn't do anything.
2 sand and gravel.
2 groups might get one type of water. 2 groups will get another type of water, and 1 group will get the last one. So each of you will be testing a different type of water to see which material cleans that type of water, okay? We are testing them, though, one material at a time.
Oh, you guys are cute.
Ready, go.
So take it out.
Oh my gosh, look at it. There's only a little bit of particles. Right? It's the tiniest bit of particles.
First we tried the screen. The screen didn't work a lot, so then we tried the paper filter. Still didn't work. So we just tried the gravel. The gravel worked perfect, but it still had the little particles in it.
A lot of you made some very good observations because you were very excited to come and tell me. Turn to page 36. Based on, don't write anything yet. Now, based on the information that you gathered today on the different testing materials, I want you to answer 3-7 because we made predictions before we started. How many of our predictions actually either came true or how many predictions were wrong? And it's okay if they were wrong. Okay, good, good. Now what I want you to do is do 1, 2, and 3. You're going to circle the materials that you would best use for your design.
If you could use only one material, which one would you use? The paper filter.
Paper filter.
It makes it lighter. It takes out the particles.
Okay, now really quick question. What was one of the best materials you could say that your group used to remove a lot of the contaminants, the particles from your water?
Paper filter.
The paper filter. Does anyone agree with Nalia? I think we have. Why do you think the paper filter was the best one?
Because no particles.
Okay. She said because they didn't leave behind any particles. Now, what do you think is the worst material? The material that really didn't work that well?
The screen?
The screen. Kaylin?
Because there was still a lot of particles in the container.
There were still particles in the water after using the screen. Okay, so what we're going to do is we're actually going to finish this off for today. Tomorrow, I want you to keep in mind that tomorrow we're actually going to be designing and creating our own water filters using a combination of different materials. I like the hands-on portion of this lesson. I feel that it's very important to learn by doing, not just by listening and watching. They have to make their own mistakes. That's the only way they'll learn. They have to, I guess their predictions, they have to either figure out if they're true or if they're incorrect. So it was kind of nice when they predicted certain things would work out, and at the end it was like, no, our predictions were wrong. And to me that's great because it shows them, okay, you were wrong and it's fine. Now you have to use what you've learned and use it to actually benefit you in the future. I know a lot of teachers tend to be scared with the idea of sand and gravel and water with dirt because they're afraid of the students playing with it. I make it a very important objective to tell my students, these are not toys. You could observe them, touch it if you need to, move it around, that's fine, as long as you're doing it to gain information, not just to waste time. And expect there to be messes. You are working with water, you are working with materials, and you are working with students. Just make sure that there are guidelines to it.